Do you remember what y equals natural log of x looks like? Any idea? What y equals natural log of x looks like? I think it's similar to that right there. Something like that would be the natural. So if that's the natural log graph, how would you find its derivative? It's all positive. Does it start off big or small? Big. So kind of like that. Do you agree? Now, the problem is figuring out an equation to match that graph is kind of difficult because we know equations that match the same thing that also has it on this side, the rational functions. Okay? So technically, even though when we decide what the derivative of a natural log of x graph is, we're actually going to use the rational function, even though part of it really isn't part of the derivative. But it'll be okay because where we define ln of x, the derivative will be correct. Does that make sense what I'm saying? So the derivative we come up with is not really the complete derivative, but there's more pieces to it. But any place that we choose for ln of x, its derivative would match. Because we can't have negative values. We can't put in negative values for x's and get anything. So those values wouldn't matter anyway. So when we define it, it's okay to define it that way. Okay? Alright, here's the derivative. One over x, that's a rational function, right? Now, when the chain rule is involved, is when you have like ln of something else. Because you know the chain rule is going to be involved the way it is with the sine and the cosine and tangent and all those others. So the rule itself, yes, you do 1 over the bottom. But then the inside part is where you have to worry about the chain rule. And so you find the derivative of the inside, which is 2x. You can leave it like that. Most of the time you would see it written this way. Questions about that? So let's say you have something like this. You would start off with 1 over that. Anytime you have 1 over a fraction, what that means is really that you just flip the fraction. So instead of me writing it out twice, that's basically what's happening. When you do 1 over that, you get this down here. Does that make sense? Because 1 over a fraction, you just flip the fraction basically. But then you have to multiply by the derivative of the inside. Okay? And when you multiply by the derivative of the inside, I'm multiplying by the derivative of what's up here. Like that derivative, the derivative of that. I don't multiply by the derivative of x plus 1 over x. That's just what I get when I do 1 over. Does that make sense? Okay, so then how do I find the derivative of the inside? Quotient rule. Good. So bottom times derivative of the top, which is 1, minus top times derivative of the bottom, which is 1, over the bottom squared. You see anything you could do? So I could do x plus 1 minus x, that gives me 1, right? Okay, anything else that you could do? See, really, all of that, all the top is x plus 1 times 1. All the bottom is x times x plus 1 squared. I can get rid of one of these x plus 1s because one of them's on top and one of them's on bottom. And I'm left with 1 over x times x plus 1. Does that make sense?
Did you do the x plus 1 squared?
About natural logs, just, it's not a hard one, but it's something different. Now I will show you that you could find the derivative the way I said, but there's something easier. I'll show you that in a second. But the first part would be 1 over e to the 10x, is that correct? Times the derivative of the inside. What's the derivative of the inside? E to the 10x times 10. Good. What does that simplify to equal? 10? Because really all of this is on top. It's really e to the 10x times 10 over e to the 10x. And you get 10. Does that make sense? Now I want to show you there's an easier way, and this is just if you recognize what's going on with natural logs. But there's a rule about natural logs and logs that when you have natural log or log of something and you raise it to a power, the power can come down in front of the natural log or the log. Does that sound familiar? That was a rule that you did probably last year or so. What's natural log of e? 1. I want you to know that. So really, this whole equation equals 10x, so what's its derivative? 10. That's an easier way to do the problem if that way makes sense to you, that you can do that with the powers. Questions about that? Okay. And then let's do one that involves a sine or a cosine, just so that you could practice it. Alright, see if you can do that one. That they would go ahead and simplify that. What's cosine of something over sine of the same thing? Tangent. It's cotangent. When the cosine's on top, that's cotangent. So it's possible that they could write the answer this way. And I just want to show you that. I'm okay with you writing it as cosine over sine, but if the answer is changed, like if it were multiple choice, just be aware that that could happen. Does that make sense? Okay. One more thing about natural logs I should have showed you just a second ago. If you have e to the ln of x, there was a rule about that. Another rule like in pre-calculus probably that you learned. But do you remember what e to the ln of x equals? It equals x. Yeah, if you have e to the ln of something, it equals the something. So if I wanted the derivative of that, what would the derivative be? 1. This particular one, if you try to do it like, okay, the derivative of e to the power is e to the power times the derivative of the power. If you try to do that way, you won't get down to 1 as your answer. Whereas on that other problem I was showing you, there are 2 ways to do it, and you both ways you get the same answer. On this one, without changing it, you won't get down to that simple answer. And so it's just a rule that you need to know. Okay? So let's do another example similar just to make sure. Y equals e to the ln of x squared minus 5. What does that equal? Not in terms of the derivative, but just in terms of what it equals. X squared minus 5. So then find the derivative, and the derivative is 2x. Okay, let's talk about arctangent and arcsine. Do you remember even what arcsine is?
Isn't it like a little -1 thing on the calculator?
Okay, so on the calculator, it looks like sine to the -1 of x. So you remember what that is? Or what that means? It's the inverse. Okay, now you've got to be very, very careful. Sine to the -1 of x, meaning the inverse, is different from sine of x to the -1, which is 1 over sine of x. 1 over sine of x is not the inverse. Okay? So the tricky thing here is that there is something when you have a -1 power, and then there's something called the inverse. So what they do in calculus is we say if you see sine to the -1, that means that we're talking about this one right here. If you see arcsine, we're talking about this one. And that way there's not question about, well, it's got a -1. I wonder if that means I put it on the bottom or if that means it's an inverse. They make the distinction in calculus. Okay, the distinction is, let's call it arc sign so we don't have to worry about the -1 if we're talking about the inverse. That's the reason they don't write sine to the -1 of x, because there's a question about which way it means. That's the reason they came up with this thing called arc. Okay? Now, we're saying that it means inverse. So before we talk about the derivative, let's say that I wanted to know arc sine of 1. What does that mean? If I wanted to find out what arc sine of 1 was, like what the answer would be. Even if you don't know what the answer would be, what kind of answer should you get? If it's the inverse, like if I say I want sine of 90, that's where I might get a fraction or a number. But the inverse is going backwards. So arc sine should mean that I'm getting an angle as the answer. This is asking me, when I think about the unit circle, and I think about these points right here, it's asking me what angle gives me 1 when I take the sine of it. And so think about, okay, the unit circle, I know that sine is the y value, so I'm thinking about the place where the y value would be 1. Where would the y value be 1 here? At 90. This gives pi over 2. When I say arc sine of a number, it's asking for an angle as an answer, because it's the inverse of what sine would be asking you. Sine would give you an angle and ask you for the number. That's why it's backwards like that. Okay? Does that make sense? Now, is that a huge important thing that you're going to have to know? Well, it's not huge, but if they ask you to find the derivative of arc sine of x at pi, or at 1, they wouldn't say at pi over 2, at 1 or at 0, you've got to be able to find the derivative and then plug in the value. So being able to find it is important, but it's not huge. Alright, so now that you know what all that means, now for the fun part. These two rules, there's a whole process of where they come from, and the book shows you a little bit of it, but it doesn't show it all to you. At this point, I'm not going to go through where it comes from, but if you're interested, we can look at it later. I think the important part is knowing how to use the rules. I will tell you that something that helps me to remember the difference, because a lot of times you'll get it for now, but then later on you'll remember, oh, I don't remember if it has a plus or if I don't remember if it has a minus, which one has a square root. Okay, this is kind of silly, but you see there's an S right there, arc sine. You see there's a square root and a subtraction sign. All the S's are together. Okay, the arc sine has the square root and the subtraction sign. Okay, arctan has a plus. That looks like a T. Kind of silly, but maybe that'll help you remember it. I don't know. Arcsine has all the subtraction things and the square roots. But arctan, it looks like a plus when you add, so I don't know. Okay, so let's talk about how we use it. Alright, let's say you have arcsine of x squared minus 1. And I want to find the derivative. That's the derivative. I'm trying to find the derivative of arcsine of something. So the derivative of arcsine of something is 1 over the square root of 1 minus that something, whatever's in parentheses, squared. And again, we have to use the chain rule, times it by the derivative of what's inside. So we're going to times it by 2x. And I'm just going to go ahead and put it on the top, because I know that when I times it by that, it'll end up being on top. You can leave it like that. You don't have to square that out. It does, I guess, simplify more underneath the square root, but you can't take the square root of it. You just have to leave it. Questions? The answers are not going to look nice, but it's kind of the same process. Okay, let's do an arctan one. Let's say you have arctan of the square root of x. So the derivative would be 1 over 1 plus square root of x squared. Do what? It'll eventually make an x, yes. But I'm not finished because what now do I have to do? Multiply by the derivative of the top, or of the square root of x. You can put it on top if you want to. I would be okay with that answer after you square the square root. Since it's just squaring the square root, that doesn't really involve a lot. It's okay to do that. But is this an okay answer? Are those two things the same? They are. You don't have to write it that way. I would really just be okay with 1/2 x to the negative 1/2 over 1 plus x. I would really be okay with that. Okay. Or if you had it 1 over that times 1/2 x to the negative 1/2, I'd be okay with that. Okay. But that could possibly be a multiple choice answer. So I want you to see that they might write it a different way. Questions? Okay, a couple more just things about arcsine and arctan that's kind of interesting. If you have arcsine of sine of x, and also if you have sine of arcsine of x, I could use my rules about arcsine and sine to find these two derivatives. Okay, but this is saying sine of sine inverse of x, or sine inverse of sine of x. We're doing the composition of sine and its inverse. Do you know what that equals? Not related to the derivative at all. They both equal x. Because this is saying, okay, figure out the angle that gives me x. Well, let's figure out whatever angle it is. Then once I figure out the angle, I'm going to take sine of that angle. Well, if I'm figuring out the angle and then I have to take sine of the angle, I'm going to end back up with what I started with. And this up here says, let's take sine of the angle and find it. And then it says arcsine, or sine inverse of that number. Well, that will give me an angle, which is what I started with. So arcsine and sine inverse, they cancel each other out, sort of. Okay? So that equals x, which means its derivative is 1. Same thing happens with arctan and tan. Okay. Questions? The 2 rules themselves, or 3 rules themselves, are not hard, but knowing how to manipulate some of this is kind of weird. One last one. Let's say you had y equals arcsine of cosine of x. Again, I don't know why they don't do an arc cosine. Maybe I just don't know enough about it to figure it out. But apparently there is a derivative for it. I don't know what it is, but there is one. I just don't think you have to know it. Because this is arcsine and cosine, nothing really cancels. You're just going to have to do the derivative like you should. So what would be the derivative? 1 over square root 1 minus cosine of x squared, or cosine squared of x, whichever makes sense. Then what? Times the derivative of cosine, which is negative sine. Questions about that? Now, one more thing I want to show you very quickly, and I'll be done, I promise. this identity, sine squared x plus cosine squared x equals 1, right? Solve for sine squared x. What does that equal? One minus cosine squared x, right? Is that true? Okay, why is that important in this problem we're doing? Or is it important?
You can square root both sides.
Is that important? Does that help me? What's the square root of sine squared? Sine of x. What does that equal?